Hi, Deepak here. Today I'm going to look at a very important question from interview perspective also and from your own understanding perspective of big data. Of what are the different features, what features are available for the reduce and the reducer parameters. This is a very critical question which you should know, which is so basic and important question. So let's look at it. I'm gonna cover the key points is what is reducer and what the framework offers, what are the important activities in reduce operation. So first question, what reducer is going to perform the operation on the intermediate values which are generated from the map output. So map output is going to give you a list of key value, like a grouping of for each key list of all the values are going to be offered by the map job. And now you want to work on that map output and generate the final results. So it is going to, so as it is, so it is going to use that and it is going to convert uh, and perform the necessary operation like aggregation or anything and generate the final result. Next is, let us see, important point is what are the different parameters you're available when spec for using the reduce operation in your map reduce job. One is you can set up the number of reducers using the set num reduces task, which will option give you the option of setting number of reducers. You can say 1, 2, 3, 4, whatever. And hash partitioning will be used to send the map outputs to the different uh, reducers. Uh, you will be able to understand the partitioning concept in another video of mine. And then second parameter you have is setting the reducer class, which allows you to set what, as the name suggests, which reduce class is being used. Then let us look at what functions are offered by the framework. Reducer framework, uh, for using reducer, the reducer class must extend a reducer and it should be extending some exceptions like IO exceptions, interrupted exceptions, and it basically performs, it gets an, it has to define a reducer function where it has the parameters of the object for the key, then the iterable uh, of a parameter for the values, and then the context. Then the reducer basically it does three sort of things. One is it is going to do a sorting of the data. So uh, and then a shuffling. So whatever data is so you have a output which is given by the mapper is a list of key and the values. So it is not going to be sorted when it comes out of the mapper job. It will be just a list of the key and the values. So the first job is to ensure that you are sorting it and shuffling it. So what I mean is that, sorry, like the first part is to ensure that the reducer job is able to shuffle the output from the mapper. That is, if you have say two reducer job, then first reducer will pull all the values that are relevant for the first reducer. Second reducer will pull all the, I mean first reducer will pull all the keys related to first reducer. Second reducer will shuffle and pull all the keys that are related to the second reducer job. And these things is part of the shuffle operation which is taken care by the MapReduce framework. So this is the first part is the shuffle operation, and the second part is once it is shuffled and the right keys are passed to the right reducer, the next step is to sort the data which is passed in to each of the reducer. you need to sort the values before you perform your actual reduce operation. So that is the second part, because any operation that you do, it is easier done when your data is sorted. So then when you do a sort operation, it generates that iterable list of values for each every key that is generated out of the sort operation. And using that, you can use the reduce operation, which is the third operation which is given by reducer, which I just mentioned. You get the input as the key value, using which is subset of the writer comparable class, which could be a long writable, or it could be a text, or it could be an integer. And you have a iterable list of values coming out of the sort phase. So there you can get those list. And next is the context, so that allows you to write the output of the reduce operation. So finally you will be, based on a reduce operation that you will do a context dot write, where you will write the output uh, for each key, what is the output. And typically in your system, you can set the number of reducers um, based on the available number of containers that are there, uh, or based on your estimated analysis of the data. So generally, if you have a huge amount of data and if you use the combiners properly, then you will not need a lot of reducers. You can control it. So typically, the question is like how many reducers you will typically use is, can keep it between 1.95 to 1.75 times the, into times the number of nodes, that is total number of nodes divided by maximum number of containers that are available per node. So it should be, say if you have two nodes and you can have maximum two containers, reduced containers, so you can have between 2 to 8 reducers. This is just a guideline, but maybe based on that volume you will be able to make a better judgment of data. So right, thanks a lot for watching. I hope this concept has got clear to you. Keep creating more videos on big data.